a word problem, you have to come up with the equation, or you have to answer questions with word problems. The other part that people find hard is when I give you a graph and you have to come up with the equation. Today's won't be as bad because you don't have any shifts yet for the first part, and then we'll move to the next lesson where we will shift. Okay, it's a little more complicated. So let's look at the first one here. Y equals A sine B theta. So if we can get B and we can get A, then you can answer this question, right? Now remember, A is just, we have decided it's positive or negative, but our A is the amplitude. Well, the absolute value is our amplitude. And our amplitude we can always get by going the absolute value of max minus min divided by 2. This is nowhere on your formula sheet. You need to have it memorized. So what I often do on your formula sheet, because you can't take it to the test anyway, is I write all the formulas on the back of it, so you know what you need to memorize for your columns, right? You have the front where you have your actual formulas. You have the back of the ones you need to memorize. So I put down on the back. So the maximum of my graph is, whoa, I'm not sure, 3, and the minimum is negative 3. So I'm going to go absolute value of 3 minus the minus 3 divided by 2, which is 6 over 2. With my amplitude then is 3. Does that mean my A value is 3? My amplitude is 3. My amplitude knows the absolute value of my A value, right? So my A value could be 3 or negative 3. So I know that my A value is either plus or minus 3. We'll deal with that in a second. Now, if I need my B value, guys, there's only one formula that helps me with my B value. If you're going to 30-2, we can open the 30-1. It's this period equals 2 pi over 2. So you need the period, you're going to use that formula. If you need B, you're going to use that formula. When you need B off the graph. Okay? So, the period equals 2 pi divided by B. Or in this case, I have to use, instead of 2 pi, 260. Because I always look at my x-axis. If my x-axis is in radians, I'm going to use 2 pi divided by B. If my x-axis is in degrees, then I'm going to use 360 divided by B. And this x-axis is in degrees. So I'm going to go period equals 360 divided by B. But I want B. So I'm going to bring B up and multiply it. And then bring C down and divide it. So B actually equals 360 degrees divided by the period. Right? So that's fantastic. We just need to now find the period of the graph. The period of the graph is how long it takes before it repeats itself. So you can go from max to max. You can go from min to min. You can go from the y-axis to when it repeats itself to that same level. Whichever one's easiest. One way is not the highway in this case, because you're going to try and pick one that either the max to max, min to min, or the y-axis to wherever it repeats itself, where it actually has a proper x value at that. If the x value is like not at the maximum, it's like off a bit, you're not going to pick that value because you don't accurately know the x value at that point. Okay? You have to be able to find the accurate x value. So this one here, I'm going to start here. If I go to max, it's okay because I have the x values there. I'm just going to figure out this probably difference, which is 45, right? Or I can go min to min because they're actually at cross sections too. Or I can go from my y, past the max, past the min, back up to that same height, and how long did it take me to get there? That number. 180? Oh, this is 180, 180, 270, so 180. So the period of this graph is actually 180 degrees. Well, if I were from max to max, would it be the same from maximum to maximum? Each of these ticks is 45, right? So this would be 45 degrees. This would be 270 minus 45, so what's that? 180 plus 45. So 225, right? Now it's 225 to 45. How much difference is that? 225 minus 45 is 180. I can go min to min. I can min to min over here, right? So there's no one way that's the perfect way to do it, but it does matter that you pick x's that it gives you. So if my max to max would have happened to have been like in the middle somewhere, it's something like this, I wouldn't pick them because they're not accurately on their value. I'd be guessing, okay? You don't want to guess. Sometimes what they'll do is in the question box above, with the information box above on the diploma, they'll actually tell you there's a maximum at this point and a maximum at this point. You have to go and label them, and they actually tell you what the maximums are at, so you accurately know your X stuff. Okay? Or they'll say a maximum and a minimum point. What if they give you a maximum and a minimum? The distance from max to min is how much of a period? Half of one. They could give you the maximum point, one minimum point, you find the distance between the X values, and you have to times it by 2, right? To get the full period. So it is sometimes they only give you a partial piece of a graph that has just a max and a min on it. So they're testing to see if you know that a max to a min is only half per period. Okay? What will they put on the diploma? They'll put an answer to you going from a max to min as the full period, right? So that would be the common error that would happen. So we're going to go 360 degrees divided by 180. And that's 2. So I know my equation is y equals, now, with the sine graph, if there's no transformations on the sine graph, right? Which there isn't any right now. We just have stretches. If there's no transformations on my sine graph starts at 0, 0, and I go immediately upwards, right? What if my A value was negative? It would flip. There'd be go downwards. There'd be a reflection in the x-axis. We're going to write a negative and stretch, right? Not a negative vertical stretch, it's a vertical stretch and a reflection in the x-axis. So my graph would automatically go this way. Look back to the same, but you're doing this. So if there's no translations and I'm going downwards right away, that means my A value is negative. This graph is going up, so my A value is positive. So I actually know that my A is not the negative version, it's only the positive version. So it's going to be y equals 3 sine 2 theta. Now, what's the great thing about these? You could, when you calculate the remote, y is remote, you can add that. Make your x min be 360, negative 360. Make your x max be 360. Make your 6 all go up by 45, so that's what it is. Make your maximum be 4. Make your minimum for y be negative 4. Make them go up by 0.5, right? Make sure it's in degree mode, because your equation is in degree mode. Put this into your y equals. If it matches, you did it right. If it doesn't match, you did it wrong. So you can always check, every time they give you a graph, you can always check your equation to see if it actually is the graph. Just make your window exactly the same as their window. Make sure your mode is in the mode they're using. And set your equation as y equals to 2. Okay? So people would say, well, what then when you not just plug all the multiple choice answers back in and get it matched? Well, they won't give it a multiple choice. They give it a numeric response, and they say y equals a sine b theta, and they can say put a in the first box, b in the second box, or what's a plus b, you know, like all of the different options. So that would be how they would have you not be able to just plug them all in. Okay? Okay. Example 4. This is like what I was saying. I was giving you a really small portion of the graph, and this looks like it's going to have quite something for a period, right? Because it's started over quite a large amount of the graph. So remember, there's no horizontal vertical translations yet, which is fantastic. My normal coast graph starts at 0, 1, and goes here and there, and just like back up to 0, 1, right? So there's a hint, what's happened here? I'm no longer up, I'm actually down. So my A value is probably going to be negative. So you try it. Get the amplitude, get the B value, try it out. Alrighty, so we want the amplitude so we can get our A value. The amplitude is the axis value of max minus min divided by 2. So our maximum value is 2. Our minimum value is negative 2 divided by 2. These will not always be the same, but because we have no vertical translations yet, they are the same for this whole lesson, right? If I vertically shift this to the up, it'll be between 0 and 4. So I shifted it up. So the actual value is 4 divided by 2, which is 2 divided by 4 divided by 2, which is 2. I know it's going downward, so I know it's going to be negative 2, right? Because normally it would be here if I didn't stretch it at all, or reflect it at all. It's normally running up here. There is normally running. It's now reflected down, so I know that my A value is actually negative 2, not positive. I need the period of my graph because B equals 360 divided by the period. And it chose 360 again because the x-axis is in degrees. However, in radians, I just 2 pi divided by, okay? So I'm going from negative 360 to 360. Or I could say I'm going from 0 to 360 times 2. Right? So it's a min to max. Either way, the period of this graph is 720 degrees. It's a really large period. It's double the normal period of sine or cosine. They're only 2. So B equals 360 divided by P. Oops, divided by 720. Which is a half. How does that make any sense that my B value is a half, that my graph is stretching out way bigger? Remember, my B value and my horizontal stretch are reciprocal of each other, right? So if the B value is a half, I'm actually horizontally stretching it by a factor of 2 over 1. So that's why it's actually stretching it. If the B value is before you've actually taken it out, then you stretch. So my equation is y equals negative 2 cos a half. Okay? Now this should be on the next page that it comes down here. Find the period and amplitude of the next given graph. So of the next graph, I want you to find the period and the amplitude and go. Not the A value, just the amplitude. So the period of this graph, the easiest one to start at, I think, is here and 4. And here, the period of this graph is 2 pi. So it's actually the original graph. Does it matter if it's the sine or cos to tell you the period is? That type of sine or cos? No, they're the same way you think. Same period. Amplitude, do I have to tell you the sine or cos? No. So it's going to be 0.5 minus negative 0.5 divided by 2, so it's 0.5. Alrighty, then we have the period of this graph, and go from max to max, which is 2 pi over 3. And then my amplitude, the absolute value of my max, which is 1 minus my min, negative 1, divided by 2, which would be 2 over 2 or 1. Or 1, 1 and 1. The period of this graph. Okay, so we're gonna go from here to here is what I'm gonna do, because that line's in a nice little tick. However, how much is that tick? Remember, if you don't know how to find the ticks, what do? You go to pi. You find out how many times pi is cut into pieces, and then you find what each tick is worth, right? So pi is here. 1, 2, 3, 4, 5, 6 ticks to pi, right? So each tick is worth pi divided by 6 ticks, right? So pi over 6. So this would be pi over 6. 2 pi over 6, which is pi over 2. This would be 3 pi over 6, or pi over 2. See, 4 pi over 6 will reduce to 2 pi over 3, right? So you have to be able to find what those ticks are worth. That's the LGD. Okay? Which is the easiest concept. You don't want to mess that up. So from max to max, it's actually pi over 2. And then my amplitude is the absolute value of my max minus my min divided by 2. So it's the absolute value of 2 minus negative 2 divided by 2, which is 4 divided by 2, which is 2. And then this one is one of those where I said they're not going to give you the full thing, right? So what I can decide though is, from here, past the max, back to that same spot, is how much of the period? Half of the period, right? I'd have to go past the min and back up to that same spot to the full period. So I know that the period is actually 3 pi times 2, so 6 pi. And my amplitude, then, this would be half of it. So I could actually just say my amplitude is 1.5, right? Because that's the part I cut the graph in half. My amplitude is from middle up, middle down. Yeah. You use the equation for amplitude. Basically, if you want to find amplitude really easily, once you do transformation. So once you get that graph and then you move it upward, it's actually up or downward. It's often quicker to just go max times and divide by 2. But if you already know the median line, you know the z value, then it is really easy to just count out from it or count down. So right now, it kind of seems silly that we're using the formula because of the fact that our midline or the middle of our graph right now is all up to that. But it will shift up or down in 2 minutes. So your amplitude is 1.5.